Logically, the length of the arrow represents the magnitude of the vector, and the direction of the arrow represents the direction of the quantity being modelled. We can then add the vector's tail to tip, and the sum, called the resultant, points from the start of the first arrow to the end of the last arrow. I encourage my students to draw their arrows in the middle of the line rather than the end, and to use 2 arrows to show the resultant. But this isn't a requirement of AP Physics or any other course as far as I know, and your teacher might require you to draw them a certain way. But I find this makes it easier to check that they're drawn tail to tip, and to identify which vector is the resultant. Here's the same vector triangle drawn without using this technique. Now let's look at how we can join these arrows. Here are the 3 vectors given in the problem, drawn to scale as vectors should be. Then we just join them tip to tail and draw the resultant from the start to the finish. Then we could either measure the length of the arrow representing the resultant with a ruler, or perhaps use Pythagoras' theorem. And we could measure the angle with a protractor or use SOLCAR-TOA to find the direction. How did I know to join them in that order? Well, actually it doesn't matter, as long as we join them tail to tip. Here they are in another order, but the resultant vector, that's the sum of the vectors, or the answer, has the same magnitude in the same direction. However, I recommend not trying to add parallel vectors one after the other, because it can become a mess. So if we started with the first vector, we'd end up with this. We can still draw the resultant from start to finish and get the correct answer, but I think it's less clear than the first 2 diagrams.